In this lecture, I am going to explain a dominance principle in the game theory. How do we reduce the size of the game? So in some games, it is possible to reduce the size of the payoff matrix by eliminating redundant rows or columns. So we have two principles: dominance principle for player A, similarly dominance principle for player B. So player A is always represented in row, player B is always represented in column. Okay, so dominance rule for player A means dominance rule for rows. First of all, what is the nature of player A? So you have to understand this concept. Then only this principle can be easily understood. Okay, right. So what is the nature of player A? Player A is maximin player. That means he tries to maximize his minimum gains. Okay. So for that, the dominance rule for rows is first we compare two rows. First we compare two rows. If all rows, if all entries in row I are greater than or equal the corresponding entries of row J. So what is the meaning of this? Row I means corresponding to strategy I. Row J means corresponding to strategy J. All payoffs corresponding to strategy I are greater than or equal the corresponding payoffs of strategy J. So in this case, since player A is maximin player, that means he tries to maximize his minimum gains. He always tries to select strategy I compare with strategy J. Since the payoffs corresponding to strategy I are more than the strategies more than the payoffs of strategy J. So in this case, player A always try to select strategy I. That means he can skip the row J. So then row J is dominated by row I. So in such case, delete row J from the payoff matrix. So that is the dominance rule for row. Okay. Since player A is maximin player, he tries to maximize his minimum gains. So we compare two rows, row I and row J. Suppose the entries of row I is are greater than or equal the corresponding entries of row J, then row J is dominated by row I. In such case, delete row J. Second principle. If each of the convex combination, in general, convex combination means we take average. The average of two rows, row I and row J, is greater than or equal the corresponding entries of row K. In such case also, the row K is dominated by row I and row J. Okay. So in such case, we delete row K from the payoff matrix. That means the player gives preference to select the strategies I and J. Okay. So overall, in rows, compare two rows, delete the row with lesser payoff entries. That means delete row in the lesser side in the inequality. Okay. So that is dominance rule for player A, that is rows. Similarly, we have dominance rule for columns, that is for player B. Right. So what is the nature of player B? Player B is minimax player. That means he tries to minimize his maximum losses. Okay. So that means he always try to select the strategy for which the payoffs are less compared with the other payoffs. Okay. So in this case, we compare two columns, column I and column J. Suppose all entries in column I are less than or equal the corresponding entries of column J. That means the payoffs corresponding to strategy I are less than the payoffs corresponding to strategy J. In such case, B always try to select strategy I. That means he skip strategy J. That means he skip column J. So then column J is dominated by column I. In such case, delete column J from the payoff matrix. Okay. So since player B is minimax player, he tries to select the strategy with low payoffs. Okay, so this is quite opposite to player A. Okay. Player A always try to select strategy with more payoffs compared with other uh, strategy. Okay. Similarly, if each of the convex combination, generally we take average of the entries of column I and column J is less than or equal the corresponding entries of column K, then column K is dominated by column I and column J. So in such case, we delete column K from the payoff matrix. Okay. So remember, in comparing columns, we eliminate the column with higher payoffs. We eliminate the column with higher payoffs. Okay. So similarly, in comparison, average of two columns with other column, you have to keep the third column entries should be higher. Okay. So this is the way to reduce the size of the game using dominance principle. Consider this problem. Players A and B each has three coins, 5 rupees, 10 rupees and 20 rupees. Each selects a coin without the knowledge of the other's choice. If the sum of the coins is an odd amount, then A wins B's coin. So A select one coin among these three coins. B also select one coin among these three coins. If the sum of the coin values is odd number, in that case A wins B's coin. That means B loses his coin to A. But if the sum is even, then B wins A's coin. That means A loses his coin to B. Okay, so these are the rules to play this game. So determine the payoff matrix, best strategy for each player and value of the game. Okay, so here we have two players. Each player has three strategies, that is 5 rupees coin and 10 rupees coin and 20 rupees coin. Okay, so for both players the strategies are same. Okay, 5, 10 and 20. So each one select a coin. If the sum of the coin values is odd amount, in that case A wins B's coin. If the sum is even, B wins A's coin. So these are the rules to play the game. So determine the payoff matrix and the best strategy for each player and the value of the game. Okay, right. So first, how do you form a payoff matrix? So right, in rows, player A has the three options, 5, 10 and 20. Player B also three options, 5, 10, 20. Okay, we have to write payoffs here. Right. Suppose player A select 5 rupees coin, player B select 5 rupees coin. What is sum of these two values? 5 plus 5, 10. 10 is even number. 10 is even number. In that case, B wins A's coin. So B wins A's coin. That means A loses his coin to B. That means A loses 5. So losses means the corresponding payoff is negative value. Okay. So this is minus 5. So the payoff corresponding to first strategy of player A and first strategy of player B is minus 5. Okay. Since sum of these two coins is 10, which is even number, the sum is even, B wins A's coin. Okay. So A's coin is 5. So B wins 5. That means A loses 5. Next, second possibility, A select 5 rupees coin, B select 10 rupees coin. Then sum of these two is 15, which is odd. So if the amount is odd, then A wins B's coin. That means A wins B's coin. Here B's coin is 10. So A wins 10. So A wins means the payoff is positive value. Okay, this is 10. Okay. Next, suppose A select 5 rupees coin, B select 20 rupees coin. So sum of these two is 5 plus 20, 25. So 25 is odd amount. In that case, A wins B's coin. Here B's coin is 20. Okay. So A wins 20. That means the payoff is 20. Okay. Right. Next, suppose A select 10 rupees coin, B select 5 rupees coin. Okay. So sum is 15. So it is odd number. Since it is odd number, then A wins B's coin. Here B's coin is 5, so A wins 5, so it is 5 plus 5. Next, A select 10 rupees, B also select 10 rupees, then sum is 10 plus 10, 20, which is even, then B wins A's coin. Here A's coin is 10, so B wins 10. That means, in other terms, A loses 10. So A loses 10 means the payoff is negative value. So A loses 10, so the payoff is minus 10. Okay. Next, A selects 10 rupees, B selects 20 rupees. Sum is 10 plus 20, 30. So 30 is even number. In that case, B wins A's coin. So that means B wins A's coin. Here A's coin is 10. So B wins 10. That means A loses 10. So the payoff is negative value. So minus 10. Okay. So similarly, write the other payoffs. Suppose A selects 20 rupees and B selects 5 rupees. So sum is 25, which is odd number. Then A wins B's coin. Here B's coin is 5. So A wins 5. So A wins means it is a positive payoff. So it is plus 5. Okay. Right. Next. Suppose A wins 20. A selects 20. B selects 10. The sum is 20 plus 10, 30. It is even number. So in this case, B wins A's coin. So A's coin is 20. So that means B wins 20. That means A loses 20. The payoff is minus 20. Okay. Next. Final. If A selects 20, B selects 20. So sum is 20 plus 20, 40. 40 is even number. So B wins A's coin. So here A's coin is 20. So B wins 20. That means A loses 20. So payoff is minus 20. Okay. So this is the payoff matrix corresponding to this game. So this is 3x3 game. Since player A has 3 strategies, player B has 3 strategies. Okay. So this is 3x3 game. Okay. Right. How do you solve this problem? First, we check whether the game has saddle point or not. Okay. For that, calculate row minimas. First, calculate maximin value. For that, calculate row minimas. First row minima. First row is minus 5, 10, 20. So minimum is minus 5. Second row minima. Second row is 5 minus 10 minus 10. Minimum is minus 10. Third row minima. Third row is 5 minus 20 minus 20. So minimum is minus 20. So these are row minimas. So maximin equal maximum of these row minimas. So that is maximum of minus 5 minus 10 minus 20. That is maximum is minus 5. Okay. So this is maximin value. Okay. So this is maximin value. Okay. Next, to find minimax value. So for that, first write column maxima values. First column is this minus 5, 5, 5. So maximum is 5. Second column 10 minus 10 minus 20. Maximum is 10. Third column 20 minus 10 minus 20. That is maximum is 20. Okay. So these are column maximas. So minimax equal minimum of these column maximas. So minimum of 5, 10, 20. So minimum is 5. This is minimax value. Okay. Right. Now observe maximin value is minus 5. Minimax value is 5. So both are not equal. So maximin not equal minimax. So game has no saddle point. That means players follow mixed strategies. That means players select more than one strategy with some probabilities. Okay. So we have to find those probabilities. Okay. Right. Since the game is a 3x3 game, next step, try to reduce this size to 2x2. Okay, by using dominance principle. If the game size is 2x2, then only we can solve. Okay, otherwise we are not able to solve. Okay, right. Next step is try to reduce the size of the game up to 2x2 by using dominance principle. Okay, reduce the size of the payoff matrix by dominance principle. So this is payoff matrix. Okay. First, start with rows. Compare first two rows. Compare row 1 and row 2. So first row element minus 5, second row element 5. So what is the relation between these two? 5 minus 5 less than or equal to 5. So here you can have any sign here, either greater than or equal sign or less than or equal sign. Okay. But the inequality should be, the same inequality should be maintained throughout the comparison, whether it is less than or equal to or whether it is greater than or equal to. Okay. So first to compare first two elements minus 5 and 5. Clearly minus 5 less than or equal to 5. Next compare second elements 10 and minus 10. So but 10 greater than or equal to minus 10. So here inequality change. Okay. So here less than or equal, here greater than or equal. Therefore first two rows are not comparable. That is row 1 and row 2 are not comparable. Okay. So leave it. Next compare row 1 and row 3. Compare row 1 and row 3. These two. Compare row 1 and row 3. So what are first elements? Minus 5, 5. So minus 5 less than or equal to 5. Second elements 10 minus 20. So 10 greater than or equal to minus 20. So here inequality changed. One is less than or equal, one is greater than or equal. So therefore row 1 and row 3 are not comparable. Okay. So leave this combination. Next compare row 2 and row 3. Compare row 2 and row 3. These two rows. Okay. So first element 5, 5. So 5 equal to 5. Second elements minus 10, minus 20. So compare this minus 10 greater than or equal to minus 20. Minus 10 greater than or equal to minus 20. Next third elements minus 10, minus 20. So clearly minus 10 greater than or equal to minus 20. Okay. So same inequality greater than or equal to greater than or equal to. You can write this equality as greater than or equal to 5 greater than or equal to 5. Clear it is. Okay. So all the three elements follow same inequality, that is greater than or equal to inequality. Okay. So that means row 2 is greater than or equal to row 3. Okay. So we have here same inequality. So row 2 and row 3 are comparable. So row 2 greater than or equal to row 3. Okay, left hand side values are row 2 values, right hand side values are row 3 values. So row 2 greater than or equal to row 3. Since these are rows, that means player A always try to select the strategy with higher payoffs. So here the payoffs of row 2 are more than the payoffs of row 3. Okay. So player A always try to select row 2. That is second strategy. Okay. So we can remove the third strategy, that is row 3. Okay. So delete row 3. Okay. So remember in rows, you delete the row with low payoffs compare with other row. Okay. So whatever the inequality here, suppose if you get row 2 less than or equal to row 3, in that case we have to delete row 2. Okay. So always delete the row with less payoffs. Okay. Right. So delete row 3. Next, go for columns. So by deleting this third row, we have only this resulting game, that is 2 by 3 game. Okay. So you have to compare the columns. First column. Okay. So this is first column and this is second column. We have to compare these two columns first. So compare column 1 and column 2. First element in column 1 is minus 5. First element in column 2 is 10. So the relation minus 5 less than or equal to 10. Next, second elements. Second element in first column 5. Second element in second column minus 10. So 5 greater than or equal to minus 10. So here we have less than or equal. Here greater than or equal. Both are different inequalities. Okay. So column 1 and column 2 are not comparable. So leave this combination. Next, another combination. Compare column 1 and column 3. Compare column 1 and column 3. Okay. So here minus 5, here 20. So what is the relation? Minus 5 less than or equal to 20. Here 5, here greater than, here 5 minus 10. So 5 greater than or equal to minus 10. We have different inequalities here. So column 1 and column 3 are not comparable. So leave this combination and check another combination. Compare column 2 and column 3. So compare column 2 and column 3. First element 10, 20. Clearly 10 less than or equal to 20. Second elements minus 10, minus 10. So minus 10 equal to minus 10. Okay. So here we have less than or equal. This equality can be written as less than or equal. We can write minus 10 less than or equal to minus 10. Okay. So column 2 and column 3 are comparable. So observe column 2 is less than or equal to column 3. Column means player B. So player B is the minimax player. He tries to select the strategy with lesser payoff. Okay. So the payoff corresponding to second strategy is less than the payoff corresponding to third strategy. Okay. So player A always try to select second strategy by ignoring third strategy. Okay. So delete column 3 from payoff matrix. Okay. So delete column 3. So that means we have removed third strategy of player A and third strategy of player B. So we get a 2 by 2 matrix. Okay. The resulting 2 by 2 payoff matrix is, that is third strategy eliminated for both players. Okay. So we have only first row, second row and first column, second column. Okay. So that is first two strategies of player A, first two strategies of player B. So this is resulting 2 by 2 payoff matrix. So we can solve this game using the previous method. So how do you solve this method? How do you solve this game? First write difference of first row minus 5 minus 10 minus 15. Take absolute value, that is 15. Write it opposite to second row. Take difference of second row 5 minus of minus 10 plus 10, that is 15. Write it opposite to first row. Next, write column differences. First column difference minus 5 minus 10. Take absolute value 10. Write it opposite to second column, that is 10. Take difference of second column 10 minus of minus 10 plus 10, that is 20. Write it opposite to first column. Okay. So after writing these differences, write probabilities. First, probability of selection of strategies by player A is P1. So this is first strategy. 5 is first strategy. So P1. So opposite value 15 by sum of these two values. 15 by 15 plus 15, that is 1 by 2. Next, 10 is second strategy. This 10 is second strategy for player A. So P2 equal opposite value 15 by sum of these two values. This is also 1 by 2. So selection of 5 rupees coin is 1 by 2. Selection of 10 rupees coin is 1 by 2. And selection of 20 rupees coin is 0. Since the third strategy is eliminated. Okay. So therefore, A of P1, P2, P3, all probabilities. A of P1, P2, P3. P1 is probability of selection of first strategy. P2 second strategy. P3 third strategy. So P3 third row is eliminated. Its probability is 0. For other two, 1 by 2 and 1 by 2. So these are the probabilities of selection of player A. Similarly, find probabilities of selection of strategies of player B. Next, probability of selection of strategies by player B is, here 5 is first strategy of player B. So Q1 equal, for this opposite value, opposite difference 20 by sum of these two values 20 plus 10. So Q1 equal 20 by 20 plus 10, that is 2 by 3. Next, 10 is also second strategy. So Q2 equal opposite value 10 by 10 plus 20, that is 1 by 3. So Q3 is 0 since third strategy is eliminated for player B. So therefore B of Q1, Q2, Q3 equal Q1 2 by 3, Q2 1 by 3, Q3 is eliminated. That is third strategy is eliminated. So Q3 is 0. So these are the probabilities of selection of strategies by player B. Next, value of the game. Value of the game is V equal, you can calculate in 4 ways. That is, calculate with respect to first column. So minus 5 into 15 plus 5 into 15 divided by sum of these two values. You get 0. So value of the game is 0. That means no gain for player A, no loss for player B. Okay. So this is the way to solve a game of size more than 2 by 2. Okay. First reduce the size of the game to 2 by 2 using dominance principle. Okay.